Okay. So, 3713, the task is you need to find longest substring where each frequency is equal basically. So fy is equal to fj for each c in that substring. Fy is frequency of c. Example basis the APPAC अच्छा इधर भी मैं इधर से क्यों देख रहा हूँ वेट अ सेकंड मेरे पास दूसरा भी स्क्रीन है ना why am I speaking in Hindi leetcode problems 12th okay so the first example is s equal to ABBAC. Second is ZZABCCY, ZZABCCY. And third is ABA. Fourth, no. Okay. So, as you can easily understand the problem statement. Problem statement is like we need to find the longest substring. In this case, this is the longest substring. By the way, I haven't seen the solutions of any of this except for one which have been asked in group to keep it spoiler free, so that like I could saw live in front of you. Okay. Uh, 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 uh. In this case, this is this ZABC ABA. Okay, so in this case it's AB. Sorry. Okay, cool. So the first thing that comes to my mind is to like let's see the constraints, and in this task the constraints are s dot length less than equal to 1000. The moment I see 1000, I can easily guess that permitted operations are at 10 raised to 6 with some constant, so it goes around 10 raised to 8. 10 raised to 8 is like the 1 second uh, limit, so that at most 10 raised to 8 operation will still be done under 1 second. At least in C++ it is true. So we try to make our solution either n log n. If it is 10 raised to 6, so we will try to get it around 10 raised to 8, and with some optimization it runs around 1 second. So hence we kinda, whenever there is like 10 is to 6 constraint, we try to find near n log n. When there is like 10 is to 5 constraint, we try to find s square root of n, which is basically another log square. Like the square root n is approximately equal to log square when n is equal to 10 is to 5. So both solutions are equally feasible in 10 is to 5. But here the constraints are small, so you can easily say that like you can easily find the or check all the substrings basically. So how to find all the substrings? So substrings is represented by ij. So again, the fixing part, fix I, move the j. Now obviously if this was my substring, my I is less than equal to j, I will start from j is equal to I will move my j is equal to I towards n. So the for loop will be also be the same. For start equal to 0, start less than n, start plus plus, and you can call it as I wrote it as start. You can again do the same thing for end equal to start. end is less than n plus plus. Okay, so this is basically the all the interval checking. So, and another thing is why you should write in these terms is because the moment you move in the incremental order, the changes in your data structure will also be in the incremental order. Hence, always prefer that you are moving in some order that is more beneficial for us, right? So here, this complexity, obviously this is uh, for each n, for each start we are doing n operations, so it's like O of n into n, so it's O of n square, and it's feasible for the given constraint. And then you need to just check if that n, if it is valid or not. Now the moment you need to, once you have like done this for loop thing, all you need to do is like, if substring is valid, substring start interval is closed, not open, is valid, then you will maximize your answer. So answer is equal to max of answer comma j minus I plus 1 here, because it's a closed interval, or start minus n, anything you can prefer. If it is open interval like on one side, then it's easy end minus start. I prefer this representation because this is easy, so that like until the bound is valid, move the new next pointer, like end pointer, always move it until the bound is valid. So if I need to find something is valid, then if you move it toward right, then in the end what will happen, this will be the non-valid bound. Same in like when you do, if you find the implementation of sort, both in any application, Java, C++, the internal sort, they will always prefer this kind of definition, start end, because it is very easy to represent intervals in terms of this and as I was saying, that let's say you have some monotonicity in your intervals, right? And your pointer is moving toward right. So when I'm moving my end pointer like this, end plus one, until it is valid, the moment it reaches this non-valid state, we know all the end minus start will have valid operations. But this is for counting. In this specific task, all we need to do is just check that substring is valid or not. So how to do that? So the first thing that comes to my mind is, if we need to check if frequency equal to fi equal to fj for all. See, so all you need to do is maintain uh, frequency set, right? So the moment our frequency increases from 0 to 1, I need to remove 0 from my subset, sorry, 0 from set, and put 1 in my set, 1 into set. You can do this kind of stuff too. So if your set end, sorry, set begin is not equal to set last element, like the last one, then it is not valid, else it is valid. uh, Another thing would be, everyone is getting like what I have written here. Please ask if you are not understanding anything. Until now we have just run the two nested loops, got the interval, and we are just checking if the string is valid or not. How we are checking is just check, it's pure brute force basically. We are just trying to compare those frequencies, if they are equal or not, just the simulation of whatever that is given in the question, like no thoughts attached.
Hi Navneet.
Yes, bro.
Yeah. Could you please go to the first uh, page and show me the question because I missed it. Yes.
The question is this, like this is the lead code daily task. You can refer it like this is today's question.
Okay. Okay. Thank you.
Yeah. So the question I will repeat again, that we just need to find the longest substring. In this case, this is the longest substring because you can see A has appeared two times, B has appeared two times. So we need to find such substring. Substring is obviously the continuous is continuous manner. So here you can see here it's 111. In ABA it's again 1 1. So answer is 2, answer is 4, answer is 4. Right. So all we need to do is just find that string substring. Right. Mhm.
Uh, So the thing you have written is 10 power 6 and 10 to 10 raised to 5. Okay. So when the uh,
Those are just constraint, like, right? Like, let's say lead code is providing you to verify your logic, right? So we don't need to test our logic again 10 is to 10, 10 is to 15, 10 is to 18, because let's say I could test my logic against in 1 second. So I will do it now. I will do it in 1 second. If I need to test my logic for like n log n complexity, so the best time is like 1 second. Hence all we do the 10 is to 8 operations, like this is the god number, like for C++ at least.
yeah, got it. Thank you.
So hence we say that like whenever there is like and most of the solutions are scaled uh, according to relative to C++ solutions, right? Like let's say Python will have 4x multiplier, Java will have 2x, like 4 second, 2 seconds, something like that. So because Python is obviously slow as compared to C++, because there are like internal operations, internal constants in Python, and same for Java. C++ is more close to machine, hence it is more faster,
Yep.
right? So this is the one.
Mhm.
And ABBA, as you can see. So again, I will not repeat the same stuff, that like we just assume whatever interval start is there, and obviously end can't be before the start, so we started from end equal to start, then end plus plus, complexity is O of n square. Okay, then 0 from set, 1 to set, because okay. How to check if it is valid? Because our frequency, this is very important concept by the way, that
Mm.
whenever frequency increases or decreases, either it goes from one uh, f to f plus 1, or either it goes from f to f minus 1, and this is very important thing. You need to remember that whenever there is a plus minus 1 update, there are so many tasks derived from this thing. Like even when we will discuss the next task, longest balance sub array, I guess. I don't know the same task the day before yesterday. Uh, so in that also they have taken the same application, that you will start from here, and if it is plus minus one, and if it is a continuous sequence, and if it is crossing the x-axis like this, then the value 0 is possible. So what we do is max minus min in that problem. So this f to f minus 1, another this is one of the applications. Another application is, we will discuss this, by the way, I have not discussed it. And another application is when you measure kinda frequency variations, like let's say you need to calculate what the maximum frequency. I have given a data structure, add x to my data structure, remove x from my data structure, and I need to find what's the element which have maximum frequency, right? So what you will do is you will create a list of list. I use it many times, by the way. This is the tricky technique I use. So let's say this is the zeroth bucket frequency. So initially every element should be here, because nothing is added. The moment I add here, this every element is virtually present 0 to infinity in this, but we will not actually add. Okay. This is another question, application of this f to f plus 1. Like whenever we kind of put it in data structure, how to do this operations. So when let's say I add 2 to my data structure. So the moment I add 2, I will put it here. Like this is the one frequency. So frequency, or like the count of 2 becomes 1, and my 2 becomes 2 comes here, right? Now what will happen when I add another 2? My count of my 2 becomes 2, right? So obviously I will store some map or unordered hash map, you could say. So my map of 2 becomes 2. So what I will do is I will push 2 here, but I will not delete 2 from here. So when I am asked like what's the maximum frequency, I will just check this top list. So this is dynamic list of list. So the moment my frequency increases, this size will be increased because this is dynamic in this direction, right? And let's say I added another 2, frequency of 2 becomes 3, like 2 to 3, and here it will be 3, and in this list I will add another 2, but I will not delete from here. Why? Because I don't need to delete, right? Now if I ask you what's the maximum frequency, I could just check this list, which is 3. But what's the element that is giving the 3? That is, you could just take the last element from this list, which is 2. Now let's say I removed 2. I remove 2. So what will happen is just I will not do anything in my data structure. What I will try to do is just decrement the count from here. So map of 2 becomes 2, and the 2 comes here, right? So now if I ask you the same question, like what's the maximum frequency element, right? So obviously it's 2, but what will happen here is I need to go through this list to clear my array, right? So I will check what was my last element. My last element was 2, right? Because my last element was 2, I will just try to verify whether that count that I am assuming is correct or not. So here the count is basically 3 because the frequency is 3, but I know that my map of 2 has become 2. So obviously this element is not valid, and I will delete this element, and this element will be deleted. Now the moment this list is empty, I will move to this list now. I will check this 2 has count equal to 2. So my max frequency is 2. This is the F minus 1 applications, by the way, like you can use it on various examples, like these are called incremental updates in short. Okay. So again, like you can do the same thing. You will again remove the 2, then this list becomes invalid. Now let's say I add 3, right? So when the moment I add 3, the 3 becomes here, right? If I add 4, it becomes here. Then I will add another 4. The count of 4 becomes 2. So here, and then I will check the maximum element, and the maximum element is 4. And if you want the latest element, then this will be 4. If you want to like the oldest element, then you will get the start. And how to delete it from the start, just swap it with the next element, and I guess that should do, no? Or you either use DQ, that's the better option. But anyway, we have shifted from the question because we need to discuss the another variations of it. Everyone kind of understood this extra task given by me, right? Like this is not the lead code task, this is the extra portion that I'm explaining you.
Do you have a reading material on this technique?
uh, just try to understand at the moment I am speaking, right? Like don't try to like take time of your own and then try to understand. Just ask me like what part you didn't understand. That's the better way of learning. Try to break it down, like right, like understand the sequence, what I said first, then what part of that you don't understand, and then try to ask me exactly at the same moment, or pause at the same moment, or like wait for me completing the section and then ask try to ask. So that's the better way to understand stuff, and that saves time for everyone. Like what part did you didn't understand, right? Like either like the dynamic list part, like what's happening in this list, what is this list showing, this is frequency by the way, these are the elements.
Uh, y- yeah. So what problem are we trying to solve in this using this technique, like, and how it solves? Like,
The task is basically you can add, remove, find maximum frequency element
hmm,
or minimum frequency element. Minimum frequency element is obviously one, maximum is the pointer you maintain
hmm.
or list or back of this list, dynamic list.
So why we create a new array for uh, for every new frequency, right? So why?
Because we need to store those number, right? Like we need to store those number which have maximum frequency. There could be multiple elements with a similar same frequency.
Ah, okay, okay, got it.
है ना? So if
Mhm.
there are multiple elements, then we can just to store those elements in list, right? And the moment we will verify that if the count matches, then my number is okay. Else I will just erase that number via pop back, something like that.
Okay.
Pop back or pop whatever. Like list has pop back, right? Okay. So coming to my original question, I will write it on another page now again, or we can create another page. Okay, so coming to the original question, like we jump to n square, like we uh, run the nested loop on start end, right? And then start and on the start end portion, we just checked if that string is valid or not. How we will check? That's another implementation. Because the frequency is increasing by one, we will just try to verify if that continuous set is if string is valid or not. Let's say the obviously the what will happen is when we move from end to n plus 1, we will not reconstruct the set again, right? Like else that complexity will become uh, n cube, right? So we don't want to do that thing. So what we'll do is we will do the incremental updates and incremental checking. What why am I using the word incremental? Because the moment you increase the frequency will always go from f to f plus 1, right? So it will be always be erased from here or somewhere. So multiple ways to implement that thing. But another way to solve this task is basically uh, mm, 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 let's say we could F2 says sorted set, and then we will just check if those frequency is equal or not. Set dot size has equal frequency or not. Unordered set is basically the hash map kind of structure, but we need the map kind of structure. So what we will do is just increment the count of map, and but the thing is the moment we create the entry, we need to erase it from map. How to do it efficiently? Mm, so start end ff plus 1. Okay, we'll try to suggest something else. All we need to check if f1 equal to f2 equal to f3. So the moment we count the frequency, I need to check if those are equal or not. This how to do this efficiently. Hmm. What logic you guys have for this task, right? Like I want to check if I am given a string, basically, like let's say I have given ABBA string, right? And in this ABBA string, I need to check if all the frequencies are equal or not.
This check will
Navneet,
be
we
constant, right?
can
Or no?
can
Okay.
we use a war operation because the same elements will disappear after that?
Same elements will disappear, right? But like there will be XOR is basically uh, 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 but XOR is just like the even count, right? Like the even count will disappear. Like
Yeah, in case of
a
even, it will disappear. In case of odd count, if the string matches.
I didn't understand. Like, could you tell me your solution? Like, what do you mean? Like,
Um, so we just wanted to see if the frequency of each character is same. So if the string length is even, if we do war, so the whole string or the array, that it will become zero, because we have each character's frequencies even, so it will become zero.
but this is also becoming zero, no?
Okay. Yeah, yeah.
So basically, XOR pair is only applicable if like you want to check something. Yeah, you could like map those to some different dimension and then kind of do the XOR thing, but not good for this task. Uh, Here you need to do the incremental frequency update. The moment you will kind of move the end. So first thing is sure that like you will move the end plus equal to 2. You can also do this optimization. Second optimization is you need to maintain the count of count, right? So if count of count is because all these elements are equal, right? So if I maintain count of element and I will also maintain count of count, so the incremental updates are still valid. Basically c count and count, I prefer this. There might be some more simpler implementation, but I think that this is the one that I would prefer for now, because this is just a hash map that one will maintain the count of count and one will maintain the count of characters, right? So let's start with this string AABBA, right? So I am starting from here and in this direction, basically I will keep adding one by one. So the moment I add a, my count became 0 to 1. The moment I add a again, my count of a sorry, my count of 0 became 1. So my count of 1 became 1. Again, count of a became 0 or 1 to 2. So the moment 1 became 2. So count of 1, count of 0. Okay. So this 1 will become 2. And what will happen is count of 1 will become 0. This goes to 0 and count of 2 becomes 1, right? And when I add b, again my count of 1 becomes 1, count of b becomes 1. Sorry for my bad handwriting. Then again b, count of b becomes 2, and the moment b becomes 2, this 1 is erased, so this 1 is decremented to 0 and count of 2 becomes 0 to 1. So now if you can check that j minus I ka length or end minus start ka length is 4. right? Because 4, I need the count to be equal, right? And there are like two characters that we have matched. So what we could say, that there are like 2 into this size of whatever this is, like count of a whatever this data structure has, like how many distinct characters are there. So 2 into like this count of 2, or you could say that like 4 divided by 2, which is like we need the count of 2 equal to total number of distinct characters. So 4 is like the string length, 2 is basically the total number of distinct characters. So we need all the distinct characters count to which is equal to 2, right? And because answer is 2, we need to verify that total 2 into 2 is equal to 4, because here you can see that count of 2 became 1. Oh, sorry, count of 2 became 1 to 2, sorry, not, because here it was 1, so it became 1 to 2. So 2 into 2 is equal to 4. You can implement it this way. Let me check if there are some more simpler solution without using count. I guess everyone is using map. Solve map. What is this? 26. No, this is the 26 into n solution. 26 n square. We don't want 26 n square. We want pure. I guess everyone is doing the same thing then. Cool. My solution is correct. Did you guys understood what I did here? I will run one more simulation of remaining characters. So when I add a, my count of a becomes 1 to 2. Now count of a becomes count 2 to 3. The moment I add 2, my count of 2 is decremented from 2 to 1, because 2 has changed to 3. So, and count of 3 will be incremented from 0 to 1. Now another a is added. So my count from 3 becomes 4. Now we know that this 3 has changed. So basically count of 3 becomes 1 to 0, and count of 4 becomes 0 to 1. We will again check the same thing, that because there are like 2 distinct characters in this string, we will do 6 divided by 2, which is 3. We will check if every character has 3 frequency. So here we can see my count of 3 is basically 0, right? I don't have any character which has like 3 count, right? So 3 into 0 is not equal to 6. Hence the complete string is not valid. But this part is valid because this length was 4. 4 divided by 2 was equal to 2. So I needed 2 count for each of them. So there were like 2 distinct characters, which is equal to 4. So 4 equal to 4, hence matched. Something like that. Everyone with me? What I did here? Everyone understood? Uh, these are basically the incremental updates. We will maintain 2 hash map. One is to maintain the count of characters, and one is to maintain count of those counts. So usual implementation related to count of count is something like this, that if I added a, my count of a becomes plus plus, right? Now what I try to do is something like this. This I call, oh sorry, count. If you are using C++, this is the best way to do this. Plus plus. And wait, sorry. This should be minus minus, I guess, in the first place. And then C count becomes the new count of A plus plus, something like this. Yeah. So you can also do plus plus. Anyway, it's the same thing. I had some trick to this. I used to do that count of A. So basically, this works something like this. So basically, this is the node. So this is dependent on this node. So if I change this node, uh, the incremental update should be there, because the state is dependent on this. So this basically this node is deleted. So the update should be propagated to this, and then it is changed. Then the update is again propagated to here, something like that. So basically here the count got 1, so this node 1 got deleted, so count here got decremented, 1 minus minus, then the count became 2 or like 0. Obviously if we add, then the count becomes 1 to 2. If we subtract, or like if we remove from the set, then count become 1 to 0. So depending on that, if it became 2 or 0, it will become plus plus count. And similarly you can add this together, that I am decrementing this, so my update will be this count plus plus, and after that this is same thing. And if you want to revert this operations, revert this entire step, you can do the same thing in reverse, that count exact same thing like the operations we are doing. So this is the order that this will be done first. So count of A is, we are doing nothing, so count of C count, and this will become minus minus, and again this was the next step after like whatever operations we did, right? If you want to, like this was, let's say, the order of operations, and we want to revert those changes done, like the same as we do in Git, right? If you want to revert those operations, what we'll do is first reverse this, first revert this, and then do this. So here this was the last one, right? Oh sorry, this was the last one, right? In order, plus plus one. So what you will do is minus minus, then this was nothing, then after that this was minus minus, you will do the plus plus, and here you will do the minus minus, order of operations. These are all the details, by the way, for implementation speed. Whatever the extra details are more for implementation speed, so that like when you implement this solution, you have some kind of support structure to your thoughts, right? Like when I think like this, uh, because this is the way that you will get faster at your implementation speed. Not just understanding the solution, you also need to be better at implementation speed. Okay, anyway, this is the extra knowledge. uh, everyone understood this solution, what exactly happened? We will do this for every n square operations, n square subarrays, obviously. How many subarrays you can count that there will be? 1 plus 2 plus 3 plus up to n, right? Like from let's say I started from n, so there will be only one subarray, right? If I started from n minus 1, there will be two subarrays, n minus 1 to n minus 1, n minus 1 to n. So until 1 n, so summation n, which is n plus 1 to 2 total subarrays. So complexity is basically n square.
Navneet, so one question.
Yeah,
Uh,
bro.
yeah, so this division that you're making, this is basically the number is coming from the length of the hash map, right? Distinct elements, right? So,
Correct. One is C. This is the formula that I will get. I needed is equal to length divided by whatever the number is there, like distinct, right? Now
Mhm.
whatever number I got needed. So the count of needed into count basically should be equal to length square of that. Got it?
Yeah.
This I'm right now 3 into number of sorry, this is the count of needed and this is the number of distinct, I guess.
So the needed is what we are finding in the count of the occurrence, how many times that is occurred, right?
This is the portion that we assume to for the valid string. Every frequency is equal. So total length divided by total distinct characters will give us the frequency that we need. And once we got that frequency, we will just check what's the count of that. If the
Exactly.
count is like if the count into number of distinct is equal to length, then that's good.
Yeah.
Okay.
Yeah.
And obviously this C count is hash map, both are hash map. So the complexity is O of 1. Hence we implement it in O of n square. Got that?
Yes.
Okay. So now what do you want to do? Like should I uh, go deep down on this task, or like obviously there will be the second portion of this, the longest balance substring 2, where like obviously n will be, I don't know, let me check what will be the n. Into there should be 2 no? Acha, the 2 is different. Like 2 is not n only, which obviously n should be 10 raised to 5. N is 10 raised to 5, and instead of multiple characters, instead of sorry, single, what I'm saying, instead of like multiple characters A to Z, there are only 3 characters A, B, C, and if all distinct characters in the substring appear same number of times. Again, it's the same thing. Okay, this is not related to the current task. So what we'll do is we will shift to the harder question, which is, where is that going? No problem, no problem. It's daily question. Acha, I guess I shifted to next question. So daily question, longest balance subarray 1. Let's solve first longest balance subarray 1. Okay. Let's see this. If it was just related to this task, then we would have done, but like that's not related, and we will waste more time, and we will not be able to discuss this one. 3719 longest balanced subarray. Okay. The task is simple. That basically it's the same task, but here we have to find longest, but the condition is different. Now we need to check if total count of events and total count, basically number of distinct event, is equal to number of distinct odd. This is the task. Like let's say 2 5 4 3. This is my array. Now you can see there are like 2 odd elements and 2 even elements, so I can consider the entire array as valid. So answer for this would be 4. There is another example, 3 2 2 5 4. So in this case, this is just 5 4 2 2 3. Okay, so 2 2 5 odd, answer equal to 4. this. Yeah. 1 2 3 2. It's again the same. There are like odd, even. So entire string is valid. So answer equal to 4. Wait. Acha, sorry. My bad. It's the total number of distinct even. Okay, sorry. Distinct even and distinct odd. So here there are like in the entire array, there are 2 is repeated. So we'll just count it once and the answer becomes 5. Same for 1 2 3 2. Answer is not 4. Basically the count of distinct even should be equal to count of distinct odd. So in this case the answer is this 2 3 2. So answer is equal to 3. Distinct element is only 2 and 3. So we will just use that thing. Okay. Cool. And constraint should be obviously lesser, like 10 is to not 10 is to 5 but around 10 is to 3. So n is less than equal to 1500. So what's your first thought, like after seeing this task, like there are like multiple components of this task. First component is obviously the balanced portion. Mm, Balanced. Second, distinct even equal to distinct odd. This is the another component. And what else? Longest that's the task. Okay, so these are the thinking points, right? These are the thinking points for us. So after seeing balanced, it's very easy that if we need to balance two things, right, we need to put one thing into one what we call it, like we can, if we want to balance two on a weighing scale, right, like, or whatever that is called, right? So we need to put some quantity here and some quantity here. So what's exactly happening is this will become plus, this will become minus, right? So if you want to do x equal to y, all you need to do is x minus y is equal to 0, or x plus y equal to 0, anything that you can represent, right? But in this case, if it would be easier if I denoted the contribution of distinct even element by +1 and distinct odd element by -1, -1 +1. So if I had 2 3 in my subarray, I will do +1 here, -1 here, and the total contribution is 0, +1 -1. So I can say this is balanced, right? Now if I want to say if I change the question, instead of balanced I will say I have I need to find in the ratio, not in 1:1, but I need in the ratio 2:3. Then what would you do? So like I need basically 2 evens and 3 odds. So what I will try to do is, for each even number I will replace it with 3. Basically I need even divided by odd is equal to 2/3. So what I need to do is replace every even number with this 3 and every odd number with 2 or -2. Now the moment I did this, I know that whatever count, now let's say I need the uh, 2 3 2 5 and 1. This is my array. Now the moment I replaced even with 3 and odd with -2, you can see my sum is coming to 0, right? So you all need to just, what you need to do is just replace those number with plus that ratio, right? And how to do it, like you can use this trick that just multiply cross. My pen shutting down. E into 3 is equal to 2 into O. So this should be the factor with that. There is a other, you can play around with this concept. This is the one component. Another component is distinct even is equal to distinct odd, right? How would you represent the distinct quantity, right? Like let's say there is 2, 2, 3. How would you represent this using, how would you represent this exactly? Because we are playing around with +1 and -1. So I need to represent the contribution using only one element of that set, right? Sorry, who raised the hand and I didn't check the messages one. Let me check. There can be duplicates. Duplicates for what exactly? Vinay? Okay.
Duplicates both uh, for even number we are saying -1 and odd we are saying +1, right?
Mm-hmm.
And there can be duplicates in even, for example, 2, 2 and 3, 3, right? There don't we overcount?
So that part, see, I broke into two components, right? I broke into balanced and distinct even equal to distinct odd. Balanced is was balanced was another task, and distinct even equal to distinct odd equal to was another task. I have just came on that part. First we discussed this, now we are discussing that part.
Oh,
है ना? Cool. So 2, 2, 3, I need to represent the same thing that we did here. Like I did -1 for even, or sorry, +1 for even, -1 for odd, right? So all I need to do is the same thing, but I need to make sure that I'm counting only once for that set. So what I will try to do, either the first occurrence, like either here, or either the last occurrence, depending on how we are moving the pointer. If you are moving the pointer from left to right, like the incremental update, right? If my incremental update is going from left to right, then depending on that, how you are implementing the data structure, you will choose the first or last element for as a contribution, right? As the contributing factor, right? So here I could represent as the first element if I'm moving my pointer to right, I to I+1, right? So here 2 was my +1 contributor and 3 was my +1 contributor. The moment I shrink my array like this, 2, 3, this +1 becomes 0 and this 2 next occurrence becomes +1. So similarly for all the elements, I will store the next occurrence of that element, and the moment my left pointer goes from I to I+1, I will try to increment this count basically. So in this case, so in this case, my I became I to I+1. So this +1 will become 0 when my array is shrinked, or basically this pointer is has been moved forward. So this +1 will become 0 and this will become +1. So using this, I know my distinct count equal to distinct odd, right? And that's it. This is the task. That all you need to do is find the longest subarray with with zero sum, with sum equal to 0. So my algorithm becomes very simple from this point. I will do the same for loop thing. For start, equal to 0. Start is less than n, start plus plus. For end equal to start, end is less than n, end plus plus. This is the incremental update because our end is moving from n to n plus 1, right? So this is the incremental update. How we will do that is basically because my end pointer is moving from left to right. So I need to make sure that whatever the contribution is there is happening due to the first element. In this case, it's very simple that whenever you found the first occurrence, you will just increment the distinct element count. Right? And you can just check what's the count of that. Like count even plus equal to count. I do something like this. If it is even, then I will just check if like this. Similarly, count odd plus equal to, if it is even, basically the number, if x is equal to even, count of x plus plus, else count of something like this. What exactly this not is doing is basically if it is equal to 0, it will return 1 or a positive number basically, because this is a binary operator. If it is 0, it will return 1. And because in C++ what happens is if the number is negative or positive, it becomes binary 1, like it returns 1 basically, in the sense of like if you write if x, and if x is greater than 0 or x less than 0, then this if condition will return true. Like this is the true for the if condition, but if x equal to 0, then that's false. Similarly, if I do not, it just means that this will increment the count, the C++ facts. Okay, so count even equal will increment the count of even and count of odd, and for each segment we will just check uh, if count of even equal to count of odd. So if count even equal to count of odd, answer is equal to obviously we will do the maximization part here, that if you got a greater answer, then we will update the answer with start minus n minus start plus 1. Everyone with me until this point?
Navneet, one question related to how did we find distinct? We will not use map. Like in this algo,
We are using map now, like we are using this thing, count x, like this here what's happening is basically whenever the count is 0, right? Whenever the count is 0, it is returning 0, it is updating to 1. So only time when the count, distinct count is increasing is when the count is getting from 0 to 1.
okay. And as you said in the not operator, if it was already there, then it will not add anything.
Yeah, exactly. If the count was 1, then this will return 0.
Hmm. Okay.
But if it was 0, it will return 1. So because we know whenever there is 0 to 1 frequency, it means we have added it to the set, right? It means it was not present in my distinct set. The moment it got the frequency got from 0 to 1, it just means that we have added to the set, count even set basically. If x equal to even,
Yeah, understood. Yeah.
else this thing. Okay, so this is the thing. This will work, by the way, like this will work for n square. This will not work for longest balance subarray 2. Now here comes the difficult part. This was the easy task. The hard one is basically n less than equal to 10 is to 5, right? So 10 is to 5 is very huge. Here n square solution was acceptable. Here it is not. We can't use the n square solution for n less than equal to 10 is to 5, right? So what do you think? Like, what should I do in this task? Okay, I will give you the hint. So basically, what we were trying to do is like we were trying to update plus one contribution for the uh, rightmost occurrence. I guess leftmost. I guess leftmost. Sorry, leftmost occurrence for that element. Leftmost occurrence of element when it is even, or for even it was +1, and for odd it was -1. So my task now became something like this. I need to find a subarray starting from, like, what I did was like two nested for loops, right? Like start and, right? So what I need to do the same thing, but I will write it little bit in a data structure way, right? For each L, for each start, you could say I need to find some end like greater than equal to start, such that sum of that start comma end equal to 0. Now this looks very simple to look, like this sounds very simple, but it is not. It is not very simple, because the moment I said equal to 0, my task becomes very difficult, right? So usually what happens is, here there comes the important observation that this was my initial algo that we are doing from for start equal to 0, start is less than n, and for end equal to start. But this for loop I have removed because I will optimize this part. This part will still remain the same. Our target is to remove this extra dimension, kick that dimension. This is common in data structure task, that we fix something, we have fixed start here, and we kick out the extra dimension, which is this for end, right? Now we need to find some start to end, right? So how we could do that? So let's say when I'm at start equal to 0, I will do the same thing, but what's exactly happening is I need to maintain something so that I could find the rightmost end where the sum is 0, right? Because I need to find the rightmost end where the sum is 0, all I can do is maintain a segment tree. Or I could do it more simple. Okay, cool. So even before segment tree, first try to understand the fact that, because my sum was always like this. If you have seen the data, that ++1 -1 +1 -1, whenever it was like +1 +1, or I will let it more gap 1, then -1, let's say, then +1, then again 1, then 1, then -1 -1 -1. Okay, so let's say this was my array, and I need to find the sorry, my point was this thing. if you see, whenever there is a change in frequency or like change in sum, so you can see it goes something like this. It becomes 1, then it becomes 0. It becomes 1 1 1 minus 1 minus 1 minus 1, right? So if you see it like this, it always, again we will put 1 more minus 1. The moment the max of this quantity, right, the max of this quantity, sum of this, right, because we can't maintain the exact structure like this, right? We need to find something, but what we can maintain, this is called semi ring, by the way. So in semi ring, what happens is we can maintain the update like plus to all. This is needed for the update, we will discuss it in few minutes, but the basic concept that is important is this thing, that whenever my mean and max, this is the prefix sum, by the way. This max is basically the maximum prefix sum and the mean is basically the minimum prefix sum. So if I need to find in this range, complete range, starting from here, I need to find if any subarray has sum equal to 0. All I need to check is until this point, what was the maximum I got and what was the minimum I got, right? So maximum I got here was 0 3. Minimum I got is 3 minus 3, which is 0 here, and again minus 1. So minimum I got is minus 1. But if you check how this 3 to minus 1 took place, it's always that because the changes are always plus 1 and minus 1, I can say that the curve is continuous. Curve is continuous and it will cross 0, right? Because it will cross 0, I can say if my max is greater than equal to 0 and if my mean is less than equal to 0, I can surely say 0 lies in that segment. And you can see here, right, like here 0 lies in this segment. Everyone understood this part, what I said?
Yes.
Okay, so if max prefix sum is greater than equal to 0, mean prefix sum is less than equal to 0, then I can surely say that like zero sum exists, and I just need to find what index is that exactly, right? Now here comes the segment tree approach. So what segment tree is? Basically segment tree is just a tree, a binary tree, but what we use this node is to represent a range, LR, right? And again, because we are kind of using that structure to our advantage, so what we try to do is break down this into, again, L comma mid comma R, right? So what we will try to do is we will maintain those updates, right? Because what was happening, as I told before, that we are moving this start forward. So this start is becoming start to start plus 1, right? The moment the start to start plus 1 is incremented, my leftmost occurrence will be changed. Here it was 0. The moment I the leftmost occurrence of 2 was 0. The moment I shifted start equal to 0 to start equal to 1, my leftmost occurrence of 2 got from 0 to 1, right? So initially the plus 1 was at this index, minus 1 was at this index, and this was 0. But the moment I changed from start equal to 0 to 1, this index got plus 1 update. This index got oh sorry, this one got minus 1 update at 0. We change start from 0 to 1, and segment my data structure or like any kind of array you can store like a brute force way. So the brute force way, this 0 at 0th index, my value was initially +1. That was the contribution I was making. So this will become obviously you can see, right? Like 2 to 3. Initially I was counting the leftmost and this was -1. The moment I shrink this array, this became +1 and this became -1. So what happened exactly here? This became 0. So if this became 0, I need to push this update into my data structures. Any data structure you can use, like whatever is applicable here. But as you can see, we are kind of doing the range update here. Like when I'm doing +1, removing this is prefix sum basically. So what prefix sum does is basically add every number. Prefix sum. I will use another page. So here comes another topic, which is like prefix sum. So what prefix sum does is basically when you do +1, you are contributing +1 to all the numbers in front of it. When I'm doing -1, like I am changing this to 0, you need to contribute that -1 everywhere in this range. When you are contributing +1 after this, like +1 here, I need to contribute +1 each number at this range. Right? So for this usage, I need segment tree. Right? The moment I change start to start +1, my data structure got updated something like this. Like whatever the index was, the initial one got updated as -1, got -1 update. If there is a next occurrence of the current x, next x. Current x is the current index of that element. Next is the next occurrence of that element. So if my array was something like 2 3 3 2, my update would be here. If I move from my start from here to here, this will contribute +1. This will contribute, initially it was +1 0 0, sorry, +1 +1 0 0. The moment I changed or shrinked my array to this, or like moved my start pointer to here, so my array became 3 3 2. My contribution became +1 0, and here became +1. So obviously this +1 is not removed. We can't just remove that. So instead of removing, we make it 0 like this. Again, my start pointer will move front. So this +1 will again become 0. And this will become 3 2 +1. Right? By the way, this was -1, sorry. So if it was -1, this will become +1. And initially this will become 0. So after this becomes 0, this becomes -1. So this becomes a balanced array. So all we need to do is find at this start what was the maximum array, something like this. Okay. So there are like various concepts involved in this. So this task is difficult. One thing is this prefix sum, that how updates are propagated forward. Right. Another thing is the max part, max mean part. Segment tree operates under this, that we will do plus operations and find maximum of that range, right? Segment tree works in this is called semi-ring, right? You can use this, and also plus min. So you need to maintain two operations on that node when you do. So obviously you are doing the range increment, so you need to find a lazy segment tree. But data structure is not the concern here. If you know that you can use data structure for this. So after this, all you need to do is, because we know max is increasing, like let's say 1 2 2 3 5 and 1 7. Now if you try to find maximum in each addition operation or addition to data structure operation, like let's say this was my set, 1, 2, 2. So here max is 1, max is 2, max is 2, 3, 5. Even after one addition, my max is still 5. After 7, max becomes 7. So as you can see, it is increasing, right? Similarly, mean will be decreasing. If I try to find mean here, it will always be 1 comma 1 comma 1 comma 1, right? So all you need to do is use segment tree to find max and mean. Now how you could check it like this. You can check if right part of that range, right, like this was L comma R or 0 comma N range, you will check if right part of range contains max comma mean, max greater than equal to 0, mean less than equal to 0. If yes, then I will have somewhere in this segment tree. But because I am always choosing, always using that node that will contain, but there are like each time my range is split into half. So 0 comma n, and here 0 comma n by 2, n by 2 comma n. So as you can see, this is divided into two part. Again, it will be divided into two part. If it doesn't lie on right side, I will move toward left side. So my priority in binary tree is to move towards right. My priority is always move towards right because I need longest subarray. Obviously, if I need the longest, I will try to move towards the right direction, right? Because right direction contains the most rightmost element. So I will move towards right pointer. But let's say there is no max greater than equal to 0 and mean greater than 0 in this node. So obviously I will move to this node. So in the end, what will happen is you will dividing by keep dividing by 2 2, right? You will end up in a single element, and that element is your zero sum. This is kind of like a binary search, but on the segment tree, right? Because all you are trying to do is you are trying to find, but in so range is splitted something like this, that I went from here, 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 something like this. So the moment I reach that node, that node contribution will be this. So this start, so your algorithm should look something like this. The for loop start wala portion is same, right? Here is the post update part, that whatever the next occurrence in update, data structure next wala portion will get the opposite element. If it is even, then it was +1, so opposite is -1. And if it was odd element, then -1 ka +1 ka update will get. And if it is ds, this is the current element removal. If there is a next element, then only we will do the update. Similarly, current x will get the same update, which is whatever the +1 -1 depending on even, and we'll do the opposite one here, not here. Okay, so this is basically the removal part, because pointer is moving forward. This is addition part, and your data structure is taking care of all those updates. Difficult one to understand. Still let me know if you are trying to, what exactly is happening here. Everyone with me? I know this is difficult one. There might be people who didn't understand anything of this, right? Like, because I have compressed so many things. What data structure? Data structure is basically segmentary. The update portion is +1 point update, but it's a range update for every number, and -1 whatever you are doing here. So ds dot update again ds dot update, and then answer is equal to max of answer, comma, my start, and data structure dot find rightmost with zero sum, right, and minus start plus 1. So the complexity of O of n square got reduced to O of n. Anyways, even if you don't understand, it's okay. Like this is a tough task, but try to understand at least this thing. This max greater than equal to 0, mean greater than equal to less than equal to 0, then obviously there will be 0 in that segment. If you, even if you understand this thing and normal plus 1 minus 1 ka contribution, then you are still learning something good in this task. Everyone with me for this one? This is very difficult task.
Yes, Navneet.
Okay. So cool. Then we will move to next task. Once again, where is this string? Okay. So this is done. Let's move to next task. LeetCode 1382 balance BST. Given a root of a binary search tree, return. Okay. 2, 3, 4. 1, 2, 3, 4. So correct 2 and 3. Okay. So we are given a root of binary associated by the same node values. And this is the same node values. So connectivity obviously will differ. No? But so this is basically a simple task. There are like multiple ways to solve this task, like 1, 2, 3, 4 you are given, and you need to find binary search tree. So binary search tree is basically if you move towards right, the same algorithm that we discussed now, that if you move towards right, no, sorry, that's a different one, basically the max one. Okay, cool. So if you move towards right, that value should be greater than the its parent value. So right child should be greater than value of parent, and left child should be less than equal to parent. And this is also our insertion rule, that if we got if this is our data structure, the moment I got new node, taking insert this here. So if node value is, let's say, x, so if this new p value is less than x, p will be inserted here, right? And let's say there was already a node present here, let's say q, and I need to insert p. So I will again check if p is less than q or p is greater than q. If it is greater than q, then I will insert it here, right? Something like this. So the recursive definition is something like this. All you will do is get the values 1, 2, 3, 4, right? Choose the mid 2 and divide the portion of distribution recursively. Solve this one like this. Again, this 3, 4 will be distributed in similar fashion, the 3, 4 and 2, 1. So 2, 3, 4, 1. As you can see, there is difference of at most 1. Why this works? Because each time you are dividing, the total depth is almost equal. So the number of height, or like number of depth required, is log, right? So each time you are dividing by 2, right? Like after this mid and 0 comma mid minus 1, and mid plus 1, and the max number. So each time you are dividing it by 2, you know that the total nodes in range are also equal, almost equal. So the log part is also same, except for the plus 1 difference, right? So the height difference will never be greater than equal to greater than 1, basically, using this way, right? Everyone with me?
Yes, yes.
Okay. So in this case, how to solve this on array? Push every node in array 1, 2, 3, 4. Then solve like this: recurse on L comma R, right? Then mid is equal to L plus R divided by 2, right? And the moment I got mid, it means like I have created a new node. So whatever the creation of procedure is, tree node R new is equal to whatever the tree node definition is with this value, which is like the mid one. So array of mid. So here comes the new tree node, basically this node, and now you will do the same recursive procedure for left. Get the value.
Yeah, it will be, I think, start comma mid minus 1, and for right mid plus 1
Nahin,
comma end.
plus 1, mid minus 1,
Yeah,
and right will be similar, which is recurse of
mid plus 1 comma end.
mid plus 1 comma r, right? But you need to make sure that each time, what's the exact definition of your range? This definition of range is that this will never get excuse me, this will never get empty, right? So L is less than equal to R. The moment L gets greater than R, because obviously we are doing mid minus 1, right? So the moment L gets greater than R, or you can just stop at L equal to R. We don't even need to go here. So the moment if L
Right.
equal to R, just return that tree node with new node creation. This one. If L equal to R. Else recurse on this thing and get left and right and attach this thing.
Right, right.
But this is the one which I am using extra O of n memory, right? Extra O of n memory. But let's say I need to solve this in O of 1 space. How will we solve it then? We just need to check the exact structure of current tree, and we need to redefine that somewhere, like re-modify it somewhere. Like here 1, 2, 3, 4. How we do that? If we need to solve in O of 1 space. 1, 2, 3, 4. 1, 2, 3, 4. Everyone understood this thing, right? Like I convert it into array and then just recursively modified the procedure. And you don't even need to sort this thing, because you were given a binary search tree, just that it was not balanced binary search tree. So all you need to do is just the in order processing.
Yeah, in order traversal will give us the sorted array.
Left, value, right. And the definition is again the same, that because the value in the left was smaller than this and value on the right was greater than this, so this definition is again recursive. So whatever the order you get using in order, it will be sorted. This is the proof you can use if someone asks you why it was sorted. Okay, cool. Let's think. There is like Morris, which modifies the structure and creates threads to parent pointer. There is balanced binary search tree, which is yeah, the red black tree kind of structure, which will just remodify if the height gets greater than 1. So here we will do the same thing, I guess, that, or but let's say there is a linear tree. What will happen then in that case? So we have the in order procedure. During that in order procedure, I need to maintain the log stack. So at most log memory. So once we done that, we will get recursively procedure. How we will do it in open space? I have no idea how we will do it. There is a mention in some material DSW. What is DSW? I guess I remember this. Like this is the one which is like compress. This is compression algorithm. So it's something like it's the same thing that I thought, but more sophisticated. O of n by 2, then O of n by 4. So the summation n wala thing becomes 2n and it becomes linear. And we need to do the compression stuff on the first elements, then singularize the list. The moment we got the list, we will get something like this maybe. If we can convert somehow the in order processing, left, right. Morris also does the same thing. Na? Morris also do the in order processing. Morris does the in order also not. Yeah, I don't remember. Yes. How did I I did the same, sorted everything. This card. Which is sorts list and then create the tree recursively. The solution actually uses more memory. I'm really not aware, so I don't care the runtime being small. 2n rotations, wine creates step. It's the same as Morris algorithm, but I don't know why they are doing the compress and all thing. So basically, how Morris works is basically it's kind of like gave the address to the latest parent pointer, I guess, the last parent pointer. This most of the O of one space algorithms are defined on that logic only, that we kind of move the responsibility to some node, because the recursive definition is on left and right, right? So we kind of move that responsibility toward the parent, and then the parent will be responsible for the movement of structure from here to here or something like that. The thread, and they call it thread creation. Similarly, this will be done in similar fashion, but in this case, they said that like we are doing the rotation thing, but I'm not getting the, because I know that this is the compress part, but Why we are doing it a complex grandparent? Let me understand it. But I will share my screen. What am I reading exactly? Where it does not require any extra memory. Okay. The idea is to convert the tree into wine like linked list using left rotations and then balance it using right rotations. You can look online the whole description of this. We will convert the initial tree into wine by doing the right rotation. We pattern a tree into linked list. Okay, that's what I thought. Where the head is formal left node and tail formal left node. Okay. So it's the same algorithm. What they have done instead is like first convert the left node. Like we are given a balanced binary search tree, right? So we start from root, and then there is a left portion. We know that the left portion will be getting merged to that the right portion. So somehow the left we will do recursively attach the next portion of root to the left portion of that whatever we got. So the modified in order tree's next portion will be root, and modified right portion will be next of root, right? So as the tree will be converted into a linked list, right? Once we convert that into a linked list, once that conversion is done, all we are trying to do is now because initially what we had was index, right? We had index, so we can easily do the recursion, but now we don't have the index, right? So to handle that, they are using some kind of like this algorithm, this for m equal to m by 2. The compression portion is same, that like make wine is the linked list that we got. But they have combined two algorithms together, make wine and grand compress. Not an interview solution, but I'm not sure.
Sandeep, what is this compression? I didn't understand.
I'm also trying to understand, bro. Like, I also don't know. Most likely, I don't know. So basically, this minus m is basically, I guess, the height of the tree, na? And log to minus one.
Yeah, it will be the height of the tree because in the perfect balanced tree, this will be the height.
No, they are making the placeholder. This m is basically the count plus one, right? Like, so they are making the placeholder. Like, if there are like five nodes, so they will make to m equal to 8, 7, 7, around 7. So this m will become 7. So the moment it becomes 7, count minus n. So count is basically total else plus count. Na? So is it round number right nodes or what exactly? Let me read it here. Convert the initial tree into wine by doing the right rotation. Flatten the tree into linked list. Calculate the height of closest perfect balanced tree. Calculate the number of nodes in closest perfect balanced binary tree. To the left row. Cover of the excited left them by 2. Divide m by 2 and repeat. Left rotate to cover of the excess of node. Left rotate m by 2 node. Divide m by 2 and repeat the step while m by 2 is greater than 0. This is floor, right? Log 2 is floor. So okay. Okay, let's see here. Our initial tree has 9 nodes and we convert it into wine like this, and we 15 collect rotation. But that's a simple linked list. Now, how is this helping to understand? And I do cut 7 nodes. Beginning of the list. So initially we perform 2 left rotation, 9 7 to cover up the excess. End of the wine. Two, three, 4 5 6 7 7 nodes. Right, if the closest perfect balance when a tree is 3. Okay, 3. And this excess node or this thing. So it contains 7 nodes. How does it contain 7 nodes?
So I think the height will be 2 raised to the power. Sorry, the number of nodes will be 2 raised to the power height minus 1, and the closest perfectly balanced tree will be of 7 nodes, right, on height 3.
That's the mask, na? Like 3 beats, like 1 1 1, like there are like 8 minus 1 7. That's a okay thing. That I understood. Hence I said, right, like this, those are placeholder things. But I'm trying to understand the algorithm itself, like what exactly happening, because I have some idea of Morris, and I think like most I'm trying to get the class of this task, right? Like understand the general logic behind this kind of
Mhm.
task, like how to convert O of 1 every time, like right? Like I don't want to under memorize this, and
Right.
so I'm trying to understand something, like trying to making sense out of this algorithm, like what's exactly happening. So most in this task they are converting it into linked list, right? Like this thing, if the algorithm, I will open the Wikipedia, I don't trust this man. 1 second. DSW algorithm, yeah. Days okay. The following is a presentation of pseudocode after it consists of main routine of 3 subroutines. The main routine is given by allocator node, the pseudo root, and makes allocate a node, the pseudo root, okay, and make the tree's actual root the right child of pseudo root. Okay. Call tree to vine with pseudo root as its argument. Call vine to tree on the pseudo root and the size of make the tree's actual root equal to pseudo root's actual rate. Dispose from the pseudo root routine tree to vine. We start from root, convert tree to vine. That is a sorted linked list. This is the important portion. So somehow we are converting our tree to sorted linked list, and then we are trying to balance on this by this algorithm, right? Vine to
Mhm.
tree. So vine is basically just a linear linked list, right? And now because as I said, right, like if we start from root, and this is not O of one memory, na, we this is O of because we are we are like are we using, where is that, are we using stack here or like just while loop, right? We are just using while loop, so it should be O of one memory. The O of one memory thing is very complex. Like I can imagine like O of how to implement in log, O of log memory, and that's good, easy to understand. But implementing it in O of one memory like this, going towards left, I guess. If and left is not a pointer, old and update the node and equal to n current pseudo root gets to right, like this old n left portion is n ka right, then this is just a swapping thing. N right is equal to old n, grand right is equal to n, right? Like else plus plus count and equal to n equal to n right. Okay, so only this is the rotation part, right? Like what we did is here is the left subtree wala portion becomes the right part of that, like the right next right pointer is pointing towards the root basically, right? If it is not, we don't care, we just do plus plus count and then get the grant. uh, Now what this excess plus plus count means is basically how many times we move towards right. All right, and once we did that, so plus plus count, uh, what does count is storing here now? Okay, so that just means that this is the modification part and this is the linked list traversal part. That modify traverse, and this is the while loop portion. So the moment we did the traversal, uh, we shifted to left, and we know the left next address is that, so we are just trying to update that, and this plus plus count will get the total number of linked list, total number of nodes in this linked list. Grandparent is equal to n equal to n right, return right, count. Okay. So at this point, n is storing the right pointer, grand is storing the, so this will reach to end of the linked list while n is not equal to null pointer. So we are storing 2 points here. One is the uh, left, one is the smaller one, and one is the greater than that. Okay, good. I understood the make wine portion now. Now let's understand the compress portion. So once we got that, we start from the grand equal to n. Uh, 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 out. This is the one which I, if grand is the downmost portion, right? Like because this is the n equal to n, right? So what's this grand? Is it root or is it the downmost node? I guess the downmost node. And then while m is equal to greater than 0, old n right and left and n. This is just a rotation part here. So if we now all we need to do is m minus minus, because we don't need to rotate the right tree, we will just need to rotate the half of those nodes. So initially we will kinda we rotate the first subtree, then half portion we don't need to rotate, then again recursively that. So m plus m by 2, no, m by 2 plus m by 4, something like that. Okay, I got the gist of it. And compress is basically just the left rotation, I guess. Return grand dot right, and grand is basically then one of uh, portion of root. The balance parameter. Okay, got it. Oh man, tough algorithm. What? I can't come up with this interview. But we can do something for the interviews. What we could do is we could just say that I will use the O of log stack space, and then I will just try to recursively keep merging them together to the root. So the moment we did that, we will get easily under log height space. We can easily convert that to a balanced binary search tree. Can we do that? Can we do that? Interesting. Anyway, stupid
Can you
algorithm.
explain the log space one? I didn't understand how.
The log space one is something like this, like you start from root, right? Now you try to convert that to first normal linked list using, but I guess that will get to the O of a height, right? Like it will go in worst case O of n, it's not log in that case. Hmm. Useless. There must be something simple this. Like obviously we will not use O of n memory, but we should be able to use something similar. So let's say I traverse in order fashion,
Hmm.
right? I traverse in order fashion. I reach towards the mid portion. Like I got the count. Let's say did one traversal and I got the total number of count in my linked list. So now I know if I'm at mid during in order, I know that will be my route. If I know that will be my route, I will just try to convert that to left portion. The right portion will be same, and I will try to recursively. This one, yeah, useless. Wait, what's Morris? Exactly. Morris algorithm, Wikipedia. Morris also does the same thing, right? Like here they are maintaining grandparent. Node. Okay, let's stop the recording, else the video will get too long. Manage recording, stop recording.